Algebra 2, this is section 4.3, dividing polynomials. We are skipping section 4.2 altogether, but section 4.3 I'm dividing into two sections. So the front side of this sheet, which is long division, is going to be the first part of, or this first video, and then tomorrow you'll watch the back side, which is synthetic division, and that's going to be an altogether different video. So this homework assignment won't be due until 2 days from now. So long division, there's two different types of division, long division and synthetic division, what you're doing tomorrow. We're going to first talk about one of the easier ways of dividing using long division, and that is with a monomial. So when you're dividing by a monomial, meaning that there's one term here, hold on just a second, one term, like 3xy, even though there's two variables, it's just one piece right here. Down here, we're going to be dividing with binomials, meaning that there's two pieces, one here, one here. So you treat each one a little bit different, but we're going to start with monomials because they are a little bit easier. So dividing by 3xy, we're going to look at each of these pieces individually. Okay, the 6x to the fourth y cubed, then the 12, and then the 18. We'll look at each one of those pieces individually. So 6x to the fourth y cubed, I'm going to write that out as its own separate piece and divided by 3xy. Okay, then we have plus 12x cubed y squared over 3xy and minus 18x squared y over 3xy. I'm just going to write each one of those pieces separately and separate them out and put a 3xy underneath of each one. Okay, now we can simplify these. So starting with this one, I look at the number 6 divided by 3 is 2. X to the fourth divided by x is x to the third power. Okay, and y to the third divided by y is y to the second power. Okay, you just like subtract a y and you subtract an x away from it. Okay, now this one, this middle piece, so this guy's done. This middle piece, 12 divided by 3 is a positive 4. X cubed divided by x is x squared, and y squared divided by y is just y. Okay, now he's done. And then negative 18 divided by 3 is 6. X squared divided by x is just x, and y divided by y goes away. Those two cancel each other out. Okay, so really you're just kind of, when you're doing the variable part of it, you're just like subtracting an x away from x squared. You're subtracting a y away from y squared. You're subtracting an x away from x cubed, okay, to get each one of these pieces, all right? And that's all the further that we can go, so that is all we have, okay? All right, now, when we get down into long division using binomials, this is where true long division comes into play. If I would give you the example, let's say we are dividing 365 divided by 2, okay? Now, we know that 2 doesn't go in there evenly, but here's what long division would look like, okay? I would say, how many times does 2 go into 3? It goes in there once, and then I would multiply it back. So 1 times 2 gives me 2, and then I would subtract the 2, and I would get 1 down here. And then I would drop the 6 down, and I would say, how many times does 2 go into 16? It goes in there 8 times. 8 times 2 gives me 16. And I subtract that, and that gives me 0, and I drop the 5 down. And then how many times does 2 go into 5? It goes in there twice. And 2 times 2 gives me 4. And I would subtract, and that gives me 1. And 1 is going to be my remainder, so it's 182 and 1/2, because I'm dividing by 2, and my remainder is 1, so it would be 1/2, okay? This is what long division looks like. You probably haven't done that since you were in elementary school, maybe. But same exact concept, except we're using x's here. So let's look at what this procedure looks like. X minus 5 is what we're dividing by, so that's going to go on the outside, and we're going to put x squared plus 3x minus 40 on the inside. Okay? All right, so just like we asked ourselves over here, how many times does 2 go into 3? We would say, how many times does x go into x squared? Or what do we have to take times x to get x squared? We have to take x times another x to get x squared. Okay? Now we're going to multiply it back through. So x times x gives me x squared And x times negative 5 gives me negative 5x. Okay, just like that. All right, so we look, figure out that x is what we need, and then we multiply it back through, okay, to get that. All right, now this next piece is one of the most important pieces. Just like we did over here, we subtracted the 2. We need to subtract this guy. So I'm going to subtract x squared, and this negative 5x I'm going to change into a positive. So you flip the signs is what I call it. All right, you flip the signs. So x squared minus x squared, that's going to go away. If it doesn't, we did something wrong. All right, and then 3x and a positive 5x makes 8x. So I write that, and then I'm going to drop my negative 40 down. Minus 40. I apologize, can't see this very well. Focus, focus, focus. Okay, there we go. All right, now I repeat the process again. So what do I have to take times x to get 8x? I have to take it times a positive 8, okay? All right, multiplying it back through, I get 8 times x gives me 8x, and 8 times negative 5 gives me negative 40. Okay, now, very important part, I flip the signs again. So 8x becomes negative 8x, and negative 40 becomes positive 40. And then I add them. So 8x minus 8x goes away. If it doesn't, I did something wrong. And negative 40 plus 40 gives me 0 as a remainder. So x plus 8 is my answer. All right, I didn't have any remainder like I did over here, so I don't have to worry about doing a fraction. Okay, x plus 8 is my answer. If I would take this guy and divide by x minus 5, I would get x plus 8 as an answer. And there you go. All right, I'm going to skip example 3. I don't like the A, B, C, D part of it, but let's go down to example 4, and we'll do part A and part B. Okay, so this one's a little bit bigger what we're dividing. All right, x cubed, this is something with 4 pieces, and we're dividing by something with 3 pieces. Okay, so let me write it out over here so we can have a little bit more room. All right, so we've got this going on here, and the inside piece is what the first piece is. So this is how you're going to set every one of these up. Minus 9x plus 18. That's how we're going to look like that. Okay, all right, so we're only concerned with really this first value of x right there, x squared, okay? So we say to ourselves, what do we have to multiply by x squared to get x cubed, okay? I need another x in there, really. X times x squared gives me that x cubed, so I multiply it back through, all right? Now, note that you only look at the x, or the starting x, to figure out what this number goes, or what this value is up here. X times x squared gives me x cubed. But now I focus on the negative 5x and plus 6 when I multiply it back through. That's the only time you look at that. X times negative 5x is negative 5x squared, and x times 6 is positive 6x. Okay? So when I multiply it back through, I get this piece right here. All right? Now, very, very important part. I go through and I flip the signs. So x cubed, I want to subtract that. Negative 5x squared becomes positive 5x squared, and 6x becomes negative 6x. Okay, so now I'm going to add the tops and bottoms. So x cubed and negative x cubed, it goes away. If it doesn't, I did something wrong. Negative 2x squared and a positive 5x squared is 3x squared. Negative 9x and negative 6x, excuse me, is negative 15x, and I'm going to drop my 18 down. Okay, now I do the procedure one more time. What do I have to take times x squared to get 3x squared? What's it missing? It's missing the 3, so I'm going to put plus 3 here, because I need a positive 3, and now I multiply it back through. 3 times x squared is 3x squared. 3 times negative 5x is negative 15x, and 3 times 6 is positive 18. Now I go through and I flip the signs, so this becomes negative, this negative becomes positive, and this positive becomes negative. I flip those symbols, and then I add them top and bottom. These are going to cancel out. Negative 15 and positive 15 cancel out. and positive 18 and negative 18 cancel out. So I end up with 0 as my remainder, and x plus 3 is my answer. Let me plug my computer in before it shuts down on me. X plus 3 is the answer. All right. The last example, part B, is the same thing, but just written in a different way. And instead of having this division symbol right here, they write it with a -1 power. Okay. So imagine that these two things that are being multiplied together, really, because there's parentheses there. All of this is over 1. To get things to become a positive exponent, what happens is you move it down below. We talked about that in section 4.1. Okay, you move that down below. So really this reads x to the 4th plus x cubed minus 6x squared minus 4x plus 14, that first piece, over x squared plus x minus 2. And that right there, that fraction means you're just dividing. So when you see that -1 exponent, that just means, hey, you're just going to divide them. Okay? So I'm going to set it up just like I did this previous one. The x squared plus x minus 2 goes on the outside, and everything else goes on the inside. Okay, just like that. All right? And now I'm going to begin. So I just look at this first piece. I underline that first piece so I know I'm just focused on him for right now. Okay? And I say to myself, I ask myself the same question every time. What do I have to take times this to get this? What do I have to take times x squared to get x to the 4th power? Well, x squared, another x squared, will give me 4, because 2 and this 2 will give me 4. All right? So now I multiply it back through. X squared times x squared is x to the 4th power. Then I do the same thing for these two pieces. Now I include them. X squared times x is a positive x cubed, and x squared times -2 is -2x squared. Okay? Now, the important part, I flip the signs. So negative, this positive becomes negative, and -2 becomes +2. Okay? And then I add. So the x to the 4ths cancel out, as they should. If they didn't, I did something wrong. X cubed and -x cubed, well, that cancels out too. That's kind of weird. Okay? And then -6x squared and a positive 2x squared gives me -4x squared, right? Minus 4x, because I'm going to bring him down. Okay? And this time, since I had two things cancel out, let's go ahead and bring the 14 down also. So plus 14, let's do that. All right? Okay, two pieces cancel out here. I usually only have one. So let's go ahead and bring both of those pieces down. All right? Now, I start with what I have down here. What do I multiply together to give me, or what do I have to multiply by x squared to get -4x squared? Well, it's missing the -4. So I put -4 there, because that's what I need. Then I multiply back through. -4 times x squared is -4x squared. -4 times x is -4x. And -4 times -2 is +8. Okay? Now I flip the signs. So this -4x becomes +4x. This -4x becomes +4x. Oh, excuse me, this should have been squared. Okay? And this +8 becomes -8. Okay? And then I add. So -4x squared plus 4x squared cancels out. The -4x, sorry, you can't see this very well. There we go. -4x and +4x, those also cancel out, and +14 and -8 become 6. And 6 is going to be my remainder, because x squared doesn't go into 6, right? X squared is bigger than what 6 is. So what I do when I have a remainder there, this 6 is positive, so I'm going to put plus, and I'm going to put 6 over x squared plus x minus 2. That's what I'm dividing by, x squared plus x minus 2, okay? And this is what my answer looks like. Kind of funny, but that's what he will look like, okay? All right, so same steps as what you would do up here when there's no x's involved, okay? All right, If that was too fast or confusing at all, go ahead and rewind this video and watch parts of it again. You can also look at some more examples in your book, or look at the way the book did these examples. That will help you also.